Ejecting. So here we're pumping water to get water, usually at distances I cannot draft. It can be really useful. It is a bit tricky and it takes a little bit of practice to get good at. Usually people are pretty interested in this topic and subject. And unfortunately, I can't claim to be a expert on it by any means, but it's a pretty cool device that we do have and is available to us, but it's going to take some work to really get to know how your ejector works. So ejectors work using Bernoulli's principle, or at least it's a significant factor in how they function. Bernoulli's principle says that an increase in the velocity of a liquid or gas will result in a low pressure area surrounding the flowing liquid or gas, which is, it seems kind of complicated, but you've all seen it. So an increase in velocity occurs simultaneous with a decrease in pressure. Think of a hose lid when you throw open a valve and all of a sudden you're flowing a whole bunch of water. That hose that was rigid is now no longer rigid. Or the paper trick. So here we have a venturi, and a venturi is a device that effectively creates a situation where Bernoulli's principle is in place. So you can see that pressure and velocity are equalized on either end of this venturi, but where it's neck down, because it's the same amount of flow, it has to move faster through that neck down piece, and my pressure goes down because it's sped up. Looking at these gauges over here, pressure goes down because the speed has increased. That is how a venturi works. And Bernoulli's principle is what makes an ejector work. So an ejector is a venturi. Let's see here. Okay, that's our venturi. So water comes in from the left, gets constrained down and speeded up right here. Okay, and it shoots across this gap and into this diffuser chamber. And because it speeds up as it's being, shot through that nozzle effectively, it creates low pressure where all those little arrows are. Right in here, which happens to be where your pickup is for water, and that would be submerged. This suction piece would be submerged in water. You normally drop the whole thing in the water. So that low pressure is lower than atmospheric pressure, just like we've been talking about with drafting, and atmospheric pressure pushes down on your water source and pushes water up into your ejector, which the low pressure piece picks up that water and pulls it into that diffuser chamber, and you get more water coming out the discharge of your ejector than you put in the inlet of your ejector. So when do you use an ejector? Okay, water source too far away. Like I've used it this way a few times. The pond is way over there. Either it's behind a bunch of trees. I can't get a draft hose. I can't get a truck over to it, or it's like a stock pond that's just got a muddy edge for several hundred feet, and you don't want to put a piece of equipment anywhere over by that. You can have somebody trudge across that mud flat and drop an ejector in the pond, string some hose back and forth, and you can eject the water out of that pond back to either a tank that you can store it in or directly into your tank on your engine. Pretty handy. I've done it a couple times. In that exact situation, we usually set up a small, like a little volume pump type of setup, ejecting back into a larger tank. Took a little bit to set up, and once it was in place, it was pretty functional for a larger fire for several days. But you can use it when your water's too dirty. That's really getting into direct ejecting, where you're pumping through the ejector and directly into your your hose lay into your fire. We'll talk about that here in a second. Water source is too far below the pump to draft. This is probably the most common use. Like you're on a bridge or something. Those first pictures that when we first opened this section, where they're out on a bridge or out on a pier or something, trying to get water out of it, and you can drop that hose down quite a ways. So this is the game on direct ejecting out to your hose lay, so to speak. Um, I'd be real cautious about doing that. The ejector needs certain pressures and volumes to make it work correctly, and they're all a little different and all a little bit complicated. So you need to get to know your ejector anyway, to make sure that you get a good pressure at the end of that. And Firestream, not only are you going to need to know your ejector, but you're also going to need to know the rest of the hydraulics. It's not that this can't work. This actually can work quite well. Um, but you do need to be a bit cautious, and you need to build your skills with your ejector to be able to do it. The idea here, as far as the whole dirty water piece goes, the ejector itself, other than it tends to have a foot valve and a strainer on it, it can suck up really dirty water. There's no pump spinning in there, and it can push that dirty water out the end of the nozzle. Now, a lot of times your nozzles will get clogged, so you're going to need a bigger nozzle, possibly. Keep that in mind. But you can definitely pull very dirty water. When we clean the wash rack at some of our old stations that still have them, and they are covered in very nasty, muddy gunk. We just fill them up with water, set up an ejector, and keep filling them with water, spraying high volume, high pressure water in, and stir up that mud, and the ejector just sucks it all right out, and it works really, really well. So be careful. I think I may have said that a couple of times. You need to get to know your ejector and how it works. You're going to have some water in the tank to start with. Um, you're going to have to fill the hose lines that go from your truck to the ejector, and from the ejector back up to the truck. Once it's fully charged, pressurized, and running at the appropriate pressure to make it work, um, you'll start the pickup. So I like to think that not only do I need to have enough to fill my hose, which would be about 9 gallons per inch and a half, and 4 for inch, but I also probably need a little bit of extra just to maintain a prime in my system in case I have any errors, any leaks. Uh, you definitely plan on having more than the minimum, because it doesn't always work perfectly right off the get-go. Generally, your ejector will be a 2-to-1 pickup. So for every um, gallon of water you push through that ejector, you will get 2 gallons of water out. So you'll pick up an extra gallon of water. Um, so it takes a while to fill that way. Every ejector is different. Some of them will pick up, 3-to-1. Some of them will do even better than that. Some of them are a fraction of a gallon per gallon. Um, every one of them is different, and generally all the ejectors we have are been sitting on the shelf for the last 50 years or more, and nobody has the manual on them anymore. So it takes some experimenting, filling up a folded tank and ejecting from one to the next, and maybe throwing a flow meter in the mix to figure out exactly what they're actually doing and what pressures they work at. They tend to work best at a given pressure. So I think the one I use usually likes about 150 psi. Um, but it's been a while. It may be less than that. And as long as you can maintain that pressure um, at the ejector, and if I remember correctly, it's a range of pressures that it works best in. So 100 to 150, something like that. You keep it around that pressure, it'll work really well. If you get outside that pressure um, range, it tends to not work, and it either may not pick anything up, um, or it may dump water out the foot valve if you don't have a foot valve on there, out the suction port. So Be cautious. Be cautious ejecting directly to a fire, because the same thing, it may or may not work unless you're in the right pressure setting, and assuming that you get the right pressure range for the ejector. Is that going to equate to the appropriate pressure out the other end of um, the ejector and out to a hose lay? If I'm looking at one line pumping one nozzle, like the picture we looked at a little bit ago, it's probably not a big deal. But I'm actually trying to pump a hose lay, it may not work very well for me. I may not have the appropriate pressure and volume functions to make that work. Let's see, straight out of PMS 419, ejectors increase water flow between 50 and 120%. And they're all different, and they come in different sizes. Not all of your ejectors are 1 inch line going in and 1.5 inch coming out. Some are 1.5 inch to 1.5 inch. Some are 2.5 inch. So you have to know what kind you have and how it works. Ejectors can lift water 80 feet or more. The more you lift and the more head pressure you create going off, say, the bridge, uh, the more the possibility exists you'll get outside that functional pressure range for the ejector. So keep that in mind when you're ejecting, and know what that range is. Ejectors can move water 200 feet or more horizontally. I've never had a problem moving water horizontally with them in general. There's friction loss involved, and you'll have to think about that as you go forward. But they can go quite a long ways. Setting up your ejector, connect an inch line to your overboard discharge on the water inlet side of the ejector. Not all ejectors run on 1 inch hose with an 1.5 inch output. Most of them do. Most of the ones we have in our caches do, but not all of them. Just be aware there are a lot of different kinds of ejectors, and you got to get to know what you have. Put a strainer foot valve in the ejector suction port. That's usually best because water will pour out that until you get everything going. Once you get it flowing, if you feel the need, you can remove that strainer foot valve. When we would do the wash rack pits, we would start them with the strainer foot valve on there. And once they were up and flowing, you could pull that foot valve off, just reach into the really nasty, icky water and unscrew it. And then you could start to pick up the bigger chunks of rocks and greatness. Okay, 1.5 inch line to the discharge side of the ejector, assuming sizes are correct. Submerge your ejector in the water source. Sounds good. Throttle up to desired output, and that desired output is going to vary by ejector, and that's part of the piece you have to experiment with. It isn't a set of rules that specifically apply to all ejectors. They are a little bit different. Try and minimize kinks. That way you're not increasing friction loss somewhere along the way, or disrupting flow. You can leave your hardware in place. I find that most people don't like to anymore, but I do.